Hi, it's Mr. Duffy. Welcome to our lesson in chemistry today. What I'm going to be showing you in this video is how to use the periodic table to find electron configurations, both extended and shorthand. This will help you a lot on your worksheet and make it a lot quicker for you to do them. If you still want to use the alphabet diagram, that is totally fine. This is just, again, another way that you can find the electron configurations. So let's go ahead and get started. Periodic table is set up in a way that it represents the different shapes, the different orbital shapes that electrons can fall into. We just have to know where they're at. So on the periodic table here, on the leftmost side, we have our s block. This is called our s block. The s electrons the s block can hold 2 electrons, and so there's, again, in each of these, there's 2 elements. The next element is the p block. The p block is the rightmost side. The s and the p group make up the main group elements. We'll talk about that next chapter when we talk about the periodic table. But this is the p block. There are 1, 2, 3, 4, 5, 6. 6 elements across the p block, and 6 electrons can go into the p block. So it kind of makes sense. The next one we have is the D block, and that's kind of like this. This is the transition metals. We'll learn about that next chapter. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 electrons can go in the D block. Now, the last block is the F block, and 14 electrons can go in there, and so there's 14 elements across the bottom as well. You'll also notice that the D block is n-1 and F block is n-2. That's because energy levels are kind of like marked alongside. There are 7 periods across the periodic table. 1, 2, 3, 4, 5, 6, 7. 7 periods across the periodic table. And that represents the energy levels that the electrons are in. And when we get to the D block for example, scandium, it's in the 4th energy level, but remember that it fills up the 4s2 first according to the lower energy, according to the Aufbau principle. But after the 4s2 block becomes the 3d block. And so what we have to do is we have to remember that we subtract 1 from the energy level, from the period, when we go to the D block using the periodic table method. So this is just one of the little hints, one of the little subtle things that we have to do when we use the periodic table method. If we're using the Aufbau diagram, you do not need to use that method. Again, just follow the arrows. The same thing kind of happens here when we're down here for the F block. We have to subtract 2 from the energy level that we're in. Another thing that's kind of confusing with the F block is where it fits into the periodic table. But if you notice, if you're going from barium, the next element to the right of it is hafnium, but the numbers change quite a bit from here to here. And what happens is you actually end up going down to the lanthanides on the bottom. So from barium, you actually go down to the bottom to lanthanum. And the reason why they do that for the periodic table is because otherwise it would make it pretty wide. So they kind of take the F block and move it down to the bottom. But really what happens, again, is that you're going from barium to lanthanum and then so forth, and then you go back up to hafnium. So just kind of keep that in mind as you're working through the periodic table. That's what's going on. Same thing for the 7th period. You're going from radium down to actinium, and then again continuing on, and then you're going to go back to rutherfordium. So let's work through some examples. Let me show you again some things that the periodic table you can use to find it when we're doing electron configurations. So the period number, like I said, is the energy level that you're in. You have to subtract for the D and the F blocks, just like I was saying in the last slide. The group number that you're in gives you the total number of valence electrons. Again, you subtract the D block out for that. We'll do a little bit more with that when we're talking about it next chapter in the periodic table. And then the column that you're in tells you the number of electrons in that block. So maybe a P3. You're in the 3rd column in the P block. That tells you you're in a P3. So a lot of different, again, periodic patterns to this. A lot of examples. Now, I think the best way to do this is just look at some examples. We're going to look at the periodic table. And so let me pull that up. And we've got the periodic table pulled up here now. Same one you have in class. If you use the periodic table, you can, on the back is the alphabet diagram. You can, again, still totally use that if you want to write out the extended or the shorthand configurations. It will work. The periodic table, again, also just works as well. So I'm just going to choose an element. I'm going to choose iron as my element here. Actually, I'll do iron second. I'll do an easier one first. Let me do sulfur. Sulfur is in the P block. I can just tell, again, based on where it's at. And so what I want to do is I want to follow along the elements till I get to sulfur. And I'm going to do the extended electron configuration. So hydrogen would be 1s1, first period, first element, S block. Helium is a little bit unique. It's in the P block, but it's really in the S block. So that's 1s2. After helium, we go to lithium, 2s1, 2s2 to beryllium. Then we're going to boron. That's 2p1, 2p2, 2p3, 2p4, 2p5, 2p6. Then we're going to go back to sodium. Sodium is in the third period. In the S block, 3s1, 3s2 for magnesium, 3p1 with aluminum, 3p2 with silicon, and then 3p with phosphorus. And finally, we get to sulfur, 3p4. So again, just to summarize that, the extended electron configuration, 1s2, 2s2, 2p6, 3s2, 3p4. I'm in the fourth column in the P block, 3p4. Again, I think that's kind of easy, kind of quick, kind of fast to do it that way using the periodic table. If I wanted the shorthand configuration for sulfur, what I would just do is I'd look back to the noble gas that's right before it, which would be neon. I'd put neon in brackets and then continue on from that point. Neon 3s1, 3s2, 3p1, 3p2, 3p3, 3p4. So it would just be neon 3s2, 3p4. That's how we use the periodic table to, again, solve for the electron configurations. They're arranged according to their electron configurations. So let's go back to iron because it illustrates kind of a little trick. Like I said before, we're in the D block, and so we have to remember to subtract for it. I'll go ahead and do the extended, and then I'll do the shorthand. So 1s1, 1s2, 2s1, 2s2, 2p1, 2, 3, 4, 5, 6, 2p6, 3s1, 3s2, 3p6, then we have 4s1, 4s2, and here's where it becomes tricky. We're going into the D block, but remember that this is in the fourth period, but now we're going to, again, subtract 1 from that. So this is 3d1, 3d2, 3d3, 3d4, 3d5, 3d6. So iron is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6, ends in 3d6. Okay. If I want the shorthand noble gas configuration, I'm going to start in argon, 4s1, 4s2, and then 3d6 again. So just remember you got to subtract from the D block. You have to subtract 1. Okay, I'm going to do one more final example. Why not? Let's do promethium. Promethium is element number 61. And since it's a little bit higher up in the electron configurations, I'm going to just do the shorthand electron configuration for it. So I'm going to go to the noble gas that's right before 61, and that would be xenon. Xenon is the element, the noble gas right before it. I'm going to start with xenon. So I write that in brackets, xenon, 6s1, 6s2. But again, after barium, I have to remember I go down to lanthanum down here. So 6s2, and then I'm in the sixth period, but I have to subtract 2 from that. So it's 4f, 4f1, 2, 3, 4, 5, 4f5. Okay, so that is how I use the periodic table to find shorthand and extended electron configurations for any element. And hopefully, again, helps you find them a little faster. But again, if you are uncomfortable using this periodic table method, you can also still use the Aufbau method on the back. It works just as well. Just got to keep track of your electrons using it. So whichever method you choose, you can still get the shorthand and extended electron configurations. And hopefully this method is helpful for you. Hopefully it makes it a little quicker, and thank you for watching.